Here I've plotted the data that is given in the tables. I kind of made up the scaling to make sure that I can fit some of these numbers in. This scaling maybe is not the greatest scaling, but generally it will work. If we take a look at this data here, we can see that for every 5 degrees of air temperature that we increase, the speed of sound increases by 3 meters per second. Okay, so this is kind of goes up proportionally and gives us what we call a linear relationship. Okay, so it gives us a straight line relationship here. Okay, in fact, we can probably extrapolate this going the other way when we go to air temperatures below 0. Okay, we have no reason to believe that it wouldn't work going in this direction. But this is a linear relationship, and because we can draw a straight line pattern through it. And linear relationships typically are characterized by some constant rate. So we increase by 3 meters per second for every increase of 5 degrees Celsius. And this a constant rate gives us something called slope. So when we look at this one here, this one, the dose of vitamins and the age, it seems to kind of not go up in a linear pattern. Although it is, if we kind of connect the dots here, then it kind of goes like that. But we could also look at a bigger picture and just kind of say, well, in general, it is going up in a straight line. And we do want to often simplify things into these linear relationships because they are a lot easier to interpret. So if I just do this, this is called what we call a regression line or a best fit line, and we try to find the best fit linear straight line equation. Okay, because we can find the equation of this line. This is what we're going to end up doing. If we have this kind of crooked line, okay, if we just connect the dots like this, it's going to be hard to describe this pattern. Although, be more accurate if I did that. We can give a more general relationship and say it's a straight line like this. So here we have the cost of the juice purchased and the number of cans of juice purchased. So if we look really closely, we can see that every second dot actually forms a straight line. There's actually 2 pretty much straight lines here. Okay, so every second can kind of follows a very straight line pattern. But again, if we want to generalize this, we can generalize this with a straight line like that. Okay, and we can find again a straight line pattern, and we're going to want to come up with this equation later on. And then again, same thing here with the air temperature and the altitude. Okay, as we increase the altitude, we decrease the air temperature, and it goes down in this straight line pattern. Okay, if I'm not mistaken, I think this one is if I draw the points relatively accurately, I think the points actually will fit this straight line. So again, there's this relationship here. So the questions ask for number 1. Okay, the question that was asked on the textbook was, it says, at constant pressure, the speed of sound in the air is related to the air temperature. Okay, so will you join the points, and we justify the answer. So we're in this case we're going to join the points because they form pretty much a perfectly straight line. Is this a function? Okay, well, does each input have only one output, or does it pass the vertical line test? Yes, it does. Same thing here. Again, in this case, we're not going to join the points because it gives us, we're better off giving this general relationship. Okay, and is this a function? Is this relation a function? Yes, it is. It passes a straight or vertical line test. So same thing here. We're not going to join the dots because it gives us kind of a crooked line. We want to generalize that straight line pattern, and again, this one is a function. And this one here, we do want to connect the dots because the connected dots does give us a straight line, and again, this one is a function.